Well, we are here at the Space Access Conference in Phoenix, Arizona with Karl Hoose of Applied Thermal Sciences. Thank you very much for joining us today.
Very welcome. Glad I could be here.
So, who is Karl Hoose? How did you get started in the space industry?
I'm not sure if we're actually in it yet. We're trying to get into it. But we started getting into it essentially last August. And the reason that we did is because we've always been into high-speed propulsion, air breathers, ramjets, scramjets. They've been looked at for decades now, but there's nothing really being used at the moment in terms of high-speed air breathers. There's still a lot of development work going on in scramjet engines. But the opportunity is that using air breathers, especially high speeds, where you can get a lot of the delta V that might be required for access to space, using some of the oxygen in the atmosphere instead of carrying it, that you could really scale the vehicle down quite a bit and maybe entertain those areas that payload sizes that are smaller, because now you see satellites and everything, really coming down in size, but you see the launch vehicles actually getting bigger because they're looking at cost per pound. And so when you take something like CubeSats, which we just kind of got introduced to last year, we started thinking, well, maybe this is an opportunity for air breathers that just hasn't been around before, because that market wasn't around. And so right now they're flying secondary payloads, and we say, hey, God, if we could do a combination high-speed air breather and rocket for a launch vehicle to put smaller payloads up into orbit, looks like there'd be a market there. So that's why we kind of jumped into that.
So, how far along is the development with the air breather? Do you chemically separate oxygen from nitrogen, or can you use all the elements in air?
No, you use the air just as it is. It's depending on the speed and altitude, ideally the duct would want to change shape. Not that it has to, it'd just be off design. And that's an area that we haven't toyed around with too much, except back in the 50s or 60s. But you use the air just as it is. You configure the duct so you compress the air, just like you'd compress it in a jet engine, except there's nothing there but you're changing the area. You inject fuel, mix it, burn it, and get the thrust out of the back end of it. So that's all it is. It's a fairly simple device. And we just want to push that more to its limits now, where we have new technology in terms of materials. Electronics have come a long way. So we're looking to utilize all the new technology that's out there now, to see if we can get these things actually up in the air and doing something even more useful than what the traditional avenues for high-speed air breathers are, such as weapon systems. If we can help develop a small launch vehicle for getting small payloads into space, where the rocket's got to be so big in order to get itself up there. If we can decrease that substantially to reduce the cost and maybe turn the time to flight and also the flight frequency way up, then I think that we would have a fairly decent market, and maybe even expand the nanosat market that's starting to develop now. So.
Well, tell me more about the combination rocket. Would you be using the air breather with solid, liquid, or hybrid rocket?
We would use the simplest. You really use all of them. Where we use the rocket now in the flight testing, because it is cheap, we boost it up to a little over the speed of sound. We boost the air breather, the ramjet, up to a little bit over the speed of sound. We separate that booster off, so it's very small. Ramjet's fairly light. And then we run the air breather. We'll run that out just as fast as we can go, which theoretically air breathers are up in the Mach 15 to even Mach 20 range, depending on how you design it. But we haven't been up there in that range, so we don't have proof that of where those lines are actually drawn. we want to get up there. But once you get up to that speed, the air breather is going to drop off, and then you're going to have a final leg that's going to be rocket propulsion into orbit. So you're going to, I mean, you still need the rocket regardless, even in a system like that, except they would be much smaller and then hopefully a lot less in terms of cost to make it, build it, fly it, so that you can really increase the flight frequency. So the combination, it's in there. We actually embed a small rocket motor in the ramjet to run an ejector ramjet mode to get it out of the gate when it's running only in the Mach 1, Mach 1.5 range, so get it up over about Mach 2, and then just run pure ramjet through the scramjet mode, and then we would transition then into the final stage and into orbit.